For 11 through 13, we're writing an equation for each periodic function. So as you might expect, these are going to be tangent functions. So for a tangent function, what I'm going to want to make sure I do is look at the same things that I look at for a sine or cosine function. I'm going to want to identify that new origin. Good news, the tangent function goes through the origin, so our new origin can be right here at the point 0, -3. So our C, D is equal to 0, -3. And then I also need to identify the A value. Now, A value is the vertical stretch. Since there's no amplitude on a tangent function, it's going to be a little bit trickier to identify. What I want to make sure of is that my 5 anchor points, which include the asymptotes, are equally spaced. So the new origin is right in the middle of a cycle. The asymptotes are the endpoints to the cycle, and the 1/4 and 3/4 of the way through points are halfway in between the middle of the cycle and the end of the cycle. If we inspect that point that's 3/4 of the way through, so just to the right of the center point, we'll observe that that is 2 units above the new origin. Normally, when we graph the parent function, that will be 1 unit above the new origin. So we've actually just found the value of A. So A is 2. And then we have to find one more thing, and that would be the B value. The B value is related to the period, and in a tangent function, 180 divided by B is equal to the period. And the period of this function is the length of one full cycle, which is 180. That's going to give us a B value of 1. So now our equation is y is equal to the A value, 2, times tangent of B, which is 1, so it doesn't have to be written, times x minus 0, so really just tangent of x, and then minus 3. So there's really no horizontal shift, there's really no horizontal stretch on this, just vertical stretch and vertical shift. All right, number 12, same approach. We're going to start by identifying the new origin, and the new origin is the point in the middle of the cycle where the graph goes through the middle of the graph. So that means our new origin, C, D, is the old origin, which is 0, 0. So there are no translations on this graph. Okay, next thing we're going to find is the A value. In order to find the A value, we have to keep in mind that the endpoints and the midpoint to the cycle are equally spaced. So if we draw those points equally spaced through the cycle, then pick the one to the right of the new origin, and we can observe that that is 3 units down from the new origin. So that's our A value is -3. That means that this graph is flipped. Normally tangent functions increase, and this one, as you go from left to right, decreases. So we found the A value. Next thing to find is the value of B. So 180 degrees divided by the B value is equal to the period. And the period of this graph is the length of one full cycle. So the cycle goes from -120 to +120. So the length of one full cycle is 240. So 180 degrees divided by B is equal to 240. If we solve that, that's going to give us 180 is equal to 240b, and dividing by 240 b is equal to 18/24, which we can reduce by a factor of 6, and that'll give us 3/4. So the equation of this graph is y is equal to the a value, -3, times the tangent of 3/4 times x. There's no addition or subtraction since there's no translation. That is to say, no new origin here. All right, let's take a look at number 13. In number 13, our new origin is right here in the middle of the cycle. So our C, D is 30 degrees, 0. So no vertical translation, but a horizontal translation or a phase shift. And then we need to identify the A value. Beginning and end of cycle, center of cycle, all points are equally spaced. So we want to find that point that is just this point to the right of the new origin. And if we go to that point, we'll find that the y value there is 2 units up from the origin. So that's our A value is 2. And now we need to find the b value, and the b value can be found by using the equation 180 divided by b is equal to the period. And so 180 divided by b is equal to, and the period is the distance from the beginning to the end of the cycle, and it looks like the period here starts at -60. That's the location of one of the asymptotes to 120. So 120 minus -60 is 180. So that's 180. That means that our b value must be 1. So our equation then is y is equal to the a value, which is 2, times the tangent of, and since our b value is 1, we don't need to have an explicit coefficient on x, but inside the parentheses, x minus the phase shift, and then +0 on the outside, so we don't need to actually write the +0. 14 through 16 are multiple guess, but don't guess. Okay, which one of these is tangent of x plus 90? So this would be the tangent function, but it would be translated 90 units, 90 degrees to the left. So our phase shift is -90 degrees. So that means, whereas this actually, in choice A, looks like the tangent function. Why? Because the tangent of -90 and +90 are undefined. The tangent of 0 is 0. The tangent of 45 degrees is 1. The tangent of -45 degrees is -1. So choice A is actually the tangent function. So what we want to do with this is translate that whole graph 90 units to the left. And if we do that, we are going to get choice C. Notice that choices B and D are graphs that decrease as you go from left to right, or fall as you go from left to right. Those would be flipped or tangent functions with a vertical reflection. So those are not going to be appropriate answer choices. All right, number 15. In number 15, we have lots of distractors there, meaning lots of alternate answer choices that aren't correct. And so what are some qualitative things that we can look at to determine or eliminate some answer choices here? So the thing that I will notice about this graph is that it is decreasing as you go from left to right. So that's a flipped tangent function. That means that we can eliminate choices A, C, E, and G. And then the other thing that we need to remember is that the base period of a tangent function is 180 degrees. In other words, the distance between asymptotes 180 degrees. Looking at this graph, the distance between asymptotes is 180 degrees. That means B is 1, so we can eliminate choices F and H. The last thing we need to do is look very carefully at whether the coefficient is -2 or -3 on the tangent function. So keep in mind that the center point to the cycle is right here at the new origin. Here's the endpoints, which are asymptotes. Find that point midway through, find the point to the right of the center, and go down to the y value there, and we'll notice that that point is down 3. That's the value of A, so y is equal to -3 times the tangent of x. In number 16, we are looking at this tangent function, and immediately I can look and see that this tangent is increasing as you go from left to right, and so that means this tangent function is not flipped. Let's get rid of choices B, D, F, and H. Then I need to figure out what is the coefficient, because that's really the only variable here. What's that coefficient inside of the tangent function? That rules the period. So the period of this function is the distance between the asymptotes, and the left side cycle begins at -120, ends at +120. So the period here of this graph is +120 minus -120, so that's going to be 240 degrees. The period of a tangent function is 180 divided by b. That's equal to 240 degrees. If we multiply both sides of this equation by b and then divide by 240, then to get the value of b, we just need to reduce this fraction. 18/24 can reduce by a factor of 6, so that will be 3/4. So it looks like the coefficient is 3/4, so the correct answer there is tangent of 3/4 x is equal to y.